450 centimeter cube. This they can also write as CC. This centimeter cube can also be written as CC. Okay, so 450 cc of carbon monoxide and 200 cc of oxygen are mixed together and ignited. So technically, a burning process happens. Now, before I may we may write do all these things. Can you tell me, a lot of questions was taken yesterday, who can tell me if carbon monoxide is burnt in the presence of oxygen, what is the product that you're going to get here? Carbon dioxide. So CO2 and oxygen, this is just rough, do not write it right away. Whenever carbon monoxide and oxygen, they are taken together, they are burnt, the result is going to be carbon dioxide. Okay. Now, what is given here is the sample of carbon monoxide and the oxygen. They both are available with us. And we need to find how much is the composition of the resulting mixture. So whatever you're going to get at the end, towards the end, so if you're getting carbon dioxide, then when they ask you composition, that means how much carbon dioxide has been obtained in volumes. So that is what the question demands here. Okay, now I will give you the format for the first question. Okay, how neatly you have to write in your exam. The format, be very careful. That's the same thing you will apply for the rest of it. But while explaining now from question number 2, I will not be writing all the format again. Okay, I will directly be taking the equation, balance it, and the quick, solving that we need to take. Only that part I will be doing. Only for the first question, I will tell you how to write the format. Okay, so very first thing is you will write the equation. So you may write down solution 1. We're taking the first one. You should first write the equation in the balanced form. So we have carbon monoxide. It's a gas. Also, it is mandatory you write the physical state, because all these that we are doing is according to the gas law. It's only pertaining to the gases. So carbon dioxide plus oxygen, which is also gas, will give us carbon dioxide, which is also a gas. Now, just to balance, we will just write 2 here and a 2 here. So now I think everything is balanced. So your first step while you attempt these kind of question is equation. And as I've already told you, equation plays a very important role. If you have not written your equation properly and you have not balanced it, then all your work will go in vain, because all your work depends only on that equation which is balanced. Now you're getting a clear idea that in the question they have not given you the product. So start your work like day 1 itself. We are taking so many equations. Get used to it, because they will not tell you what is the product. Only question part was given, the reactants were given. They have not even told you what is the product. You have to predict the product. You have to tell what is the product. So as we keep doing equation, get familiar with these terms, then you know that anytime carbon monoxide and oxygen is taken for for the burning process, it's always going to give you carbon dioxide. So you can always maintain a separate page. That is also important for this chapter, because a lot of equations will be there. Maintain a separate page where you keep writing a fixed result. So a lot of carbon monoxide questions will be there, ammonia questions will be there, hydrocarbon questions will be there, water questions will be there, formation of water. Very fixed results are there, and you need to take a note of them. So start maintaining that page. You can always like leave 1 or 2 pages, and then onto 1 page you may write down the first one. Whenever you have carbon monoxide and oxygen, it's always going to give you carbon dioxide. Okay, that's the first one we have taken. To 1 is to 2. Now when you write this, now that was our simple way, but while you write this, write 2 volumes, 1 volumes, and again 2 volumes, and this is according to the Gay-Lussac's law. So write it down by Gay-Lussac's law. Should also mention which law you are applying here, because at times we will also be using the Avogadro's law. So you have to write which law you're using. Okay, so according to Gay-Lussac's law, we are taking the volumes in ratio, and we can clearly see they're all in whole number. Okay, So this is your first step. Write the equation, balance it, and according to Gale-Lizak's law that we are writing the volumes in ratio, write down the ratios. That's the first part to do. Now you are supposed to do the calculation about how much carbon dioxide is produced. Okay, for that, what you need to do, you have to do a calculation. So carbon monoxide and oxygen, now both of them, both their volumes have been given to you, correct? Carbon monoxide, how much in the sample, in the question it is 450 cc, and oxygen is given as 200 cubic centimeter. Okay, now my first question to you all is, how will you identify the limiting reagent here? And what is meant by limiting reagent? Any idea? Do not rewrite it, it's just for explanation. I have 450 cubic centimeter of carbon monoxide and I have 200 cc of oxygen. Which one? See, a lot of children solve this thinking that whichever is least in number, take that as the limiting reagent. Like as I look into this question, I see 200, that is the least number, and that is for oxygen. So oxygen should become the limiting reagent. It is not necessary in all the cases. Okay, but you have to understand this combustion will take place only because of oxygen. Okay, how much oxygen is there, only that many oxygen will help for carbon monoxide to convert into carbon dioxide, correct? If the oxygen is going to be completely used up, let's say the oxygen has whatever 200 cc of oxygen was there, all of the oxygen got used up, it does not mean all the carbon monoxide also got ignited. Few may be left behind depending on the ratio. We will always see the ratio how it works. So in this case, the limiting reagent is going to be oxygen because it's a burning thing that happens, ignition that happens. So ignition depends on the fuel. Okay, till the time the fuel is there will be that process. Now, kind of like I may just relate it with a regular example. We have car. It can be a diesel based car, petrol based car, CNG, whatever. Let's take it's a petrol based car. You have car with you, but it runs on petrol, correct? Till the time the tank is filled up, okay, the petrol is there, the car will run. The moment petrol will get over, what about this car? Is it going to be under working condition? No, the car is not going to be in working condition. So here, when you have two situations like this, you have to decide the whole reaction is happening because of one particular reactant. So in this case, petrol will become the limiting reagent. Till the time petrol is there, the car will run. Petrol is over, the car is not going to work. So in the previous question that we had, you have to decide because both the samples volume is given to you. So should you take the sample for carbon monoxide in the question or should you take oxygen? Totally depends on your knowledge about which is the limiting reagent. So according to this question, the limiting reagent is oxygen. Okay, and till the time, and we will of course discuss, sometimes there are extra oxygen given, oxygen will be left out and the other thing gets combusted totally. That can also happen. Okay, we will have many questions based on those types as well. So now let's see. So we are going to pick up oxygen value and solve the question. So if I see carbon monoxide, I'm just rewriting it here, carbon monoxide, oxygen and CO2. Okay, their ratio is 2, 1 and 2. So I'm going to pick up from oxygen. One volume of oxygen will be equal to what is given to me in the sample. The sample, it is 200 cc. Okay, so this is the factor that's going to help me understand the remaining part. So if one volume is 200 cc, how much is carbon monoxide? Yes.
They have given it in the question as 450, right?
It is 450 as the sample. But according to the equation, one volume, if I'm picking up the reagent, the limited reagent is oxygen. I'm having 200 cc of oxygen. In that, how many carbon monoxide can be converted into carbon dioxide? That is the point. I do have 450 cc given in the sample, but are all the 450 going to be consumed? That is what we
No.
need to check. No. So 2 volume is how much?
Is it 400?
Yes, it will be 400 cc. That means in the sample they have given 450 cc, but only 400 cc will be used in the combustion process. How much is extra?
50 cc.
Correct. So there will be some unused, or you can always write unreacted or unused. These are the terms you can use: unused or unreacted carbon monoxide. How much is left out? 50 cc. It's not been used up. Why? Because we are not having that much of oxygen. So at least if I have 200 cc of oxygen, it is capable of burning 400 cc of carbon monoxide. But the extra 50, what happens to them? They are not going to be used up in the burning. They will be left behind. One volume is 200, so two volume will be
400.
400. So how much CO2 will be produced in this process? 400 CO2 will be produced. I'm just rewriting this again. So when I have a sample of oxygen, which is 200 cc, it is capable of using how many carbon monoxide? 400 cc. And how many carbon dioxide will be formed? 400 cc carbon dioxide will be formed. But in the sample, they said they gave us a sample of 450 cc, but not all of them got used up. 50 is left behind. So when they ask you resultant mixture, according to the equation, we are just writing CO2 on the right side. But then we know that there are some CO which is left behind. So in answer, how you should write? The composition of resultant mixture is composition of resultant mixture is, you have carbon dioxide gas, how much is formed? So you will write carbon dioxide formed will be 400 cc, and yes, there was some 50 CO which was unreacted. You can write it not formed, don't write CO is not formed, you will write unreacted or unused carbon monoxide. 50 of them is there. So total, how much is the mixture? 400 plus 50 is 450 cc. A combination of gas is formed. It's a mixture of gas, and this gas is a mixture of carbon dioxide and carbon monoxide. And that resultant gas is going to have a volume of 450. Is one volume of nitrogen combines with one volume of oxygen to form two volumes of nitric oxide. Luckily here the reactant and the products are given. As I said, do not depend on the question. These questions coming from the mole concept and stoichiometry, they do not expect to give you product side. Okay, so you should be very well versed with what should be the product. You have to calculate the amount of each reactant required to produce 250 ml of nitric oxide. Now first let's understand what information is given to us. We should first write the equation for that. Let me just shorten this up, and I've done this yesterday. In fact, I have given you many equations yesterday. So nitrogen combines, nitrogen is written as N2. It's a gas, combines with oxygen, so you should write O2. And when they combine, they form nitric oxide, which is NO. But of course, you need to balance it.
Put 2 in front of NO.
Correct. You will put 2 here in front of NO. Okay, now it is balanced. So that is your first work done. Second work is you write the ratio. So what is the ratio? 1 is to 1 is to 2. That's your second part. And of course, now I'm not going to be writing every time, but then when you write the ratio, write volumes. It's one volume, and two volume. And this is according to the Luzac's law. You can write Gay-Luzac's law, shortly write Luzac's law. That's all. Okay. Once you've done with all these work, now we have to know, I'm erasing the remaining part. So now what sample is given to you, they have already given this information, one volume. And that's right, one volume, we have written it here. One volume of nitrogen, correct? Then one volume of oxygen. So this is oxygen with one volume. gives 2 volume of nitric oxide. So that work they have already given to us, but yes, even if they would not have given, we know the equation to be balanced, and from balanced equation we get these already. Okay, so that part is used up. So this information has been taken up. Now we have to check the second part. We have to calculate the amount of each reactant required to produce 250 ml of nitric oxide. So they are expecting 250 ml of nitric oxide. That's the only information given to us. We don't know how much nitrogen we want, how much oxygen is needed, but we know that the result is we need to have 250 ml of nitric oxide. Okay, so I'm rewriting it here on the next screen. So it's NO plus O2 giving you 2NO with the ratio as 1:1:2. Okay, now the information given is only of this. So what is related to NO? 2 volumes. So 2 volume will be equal to 250 ml, because that they have given to us. They want 250 ml. 250 ml is representing 2 volumes. So 1 volume is how much?
Ma'am, 125.
Yes, it's going to be 125. Okay, so wherever you see 1 volume, technically how much ml it is considering? It is 125. So now we just need to know how much N2. So N2 is representing 1 volume. N2 is representing 1 volume. And 1 volume means how much? 125 ml. Oxygen is also representing 1 volume. So O2 is also having 1 volume. And 1 volume means 125 ml. And that's it. This was what they were asking. They were asking how much, amount of the reactants you need to take. So reactants are N2 and O2, and how much you need to take? 125 each. So that means if I have 125 ml of N2 and I have 125 ml of oxygen, if they are combined, it will definitely give me 250 ml of nitric oxide. This is what it means. Always, as I said, your ending statement should have amount of N2 is equal to, like that you will always write the final statement. Amount of N2 will be 125 ml and the amount of oxygen also will be 125 ml. The volume of oxygen at STP. What is STP? Standard time pressure. So it's just an extra information. You don't have to work on that unless you come towards some other conditions required for complete combustion. When I say complete combustion, that means there is no carbon monoxide left out. Okay, like in the first question, we have seen 50 cc of carbon monoxide was not used. It was unreacted. But this should not be the case here. It should be utilizing all the CO. Required for complete combustion of 100 liters of carbon monoxide at the same temperature and pressure. We're not changing temperature, pressure. If you change it, volume will get affected. But that way of solving that, we'll take it later. But first, let's do all the simple question. Okay, now you can clearly see, did they give you the result here? No RHS is given. What is the product? It's not given in the question. So as I've said, a lot of carbon monoxide ignition questions are there. So as you keep doing questions, then you are very clear with your equations.
Plus O2 gives out CO2.
Okay, tell me the balanced one. Equation
Yeah,
is right, but it's not balanced.
we'll put a 2 before CO and before
Correct,
CO.
and 2 at the end. So this is like constantly being used. So now get used to this equation, okay?
2 volumes, 1 volume, and 2 volumes.
Yes. Okay, and then giving out 2 volumes. Okay. Now, after that, what is the information we have? The volume of CO is given to us, so only that information is available. The rest, how much oxygen and how much CO2 is from that, nothing is given. So this is given to us. 100 ml of carbon monoxide is available, and we want complete combustion. We don't want it to be left out. So What is given, you will pick up that for the calculation. So every time you write it, as I said, get used to it, write by Gay-Lussac's law, like that you will write that statement every time. Okay. So 2 volumes of carbon monoxide is equal to how much? It's 100 ml given to us. Okay. 2 volume is representing 100 ml. So 1 volume will be how much? Correct. So 1 volume is representing 50. So wherever you find 1 volume in your ratio, it is equal to 50. So tell me how much will be the oxygen then? Oxygen is representing 1 volume. So how?
50 ml.
Correct. So how much in this case for complete combustion to take place, 50 ml of oxygen is sufficient for total burning. They have not asked you for the resultant composition. Okay, so here you will not do that extra work. They've only asked you how much oxygen is required for complete combustion. But that does not mean you should not write the equation. Equation is mandatory. You will be writing CO2 is formed, but it is not asked how much CO2 is formed. So you will leave your answer here. But if I may ask you as an extra question, as this, technically how much carbon dioxide is formed if it is total combustion? Presence what? 1 volume is 50, 2 volume will be 100 ml. So carbon dioxide form will also be 100 ml.
2H2 plus O2,
Hmm.
which gives 2H2O.
And always write the physical state.
2:1:1.
Yes, it should be 2 here, sorry. 2 1. Yes. Okay, now the sample is having that they have 200 cc of hydrogen and they have 150 cc of oxygen, and then they are ignited. So for ignition, for the support of burning, it requires oxygen here to form water. So let's see if all the oxygen is used, but as per the question, it seems as if not all the oxygen is utilized. So we will always use oxygen as the limiting reagent in this case. Okay, so 150 and you have 200 cc. Okay, if oxygen is remain unreacted, that means some oxygen is left out. Here, that means hydrogen is behaving like a limiting reagent. Okay, so in this case, why hydrogen? Because as for the question is being noted, you can see oxygen is extra. So oxygen, as I've said, sometimes oxygen will be left out. So it will totally depend on hydrogen. How many hydrogen were there? All got combusted or all has gone through oxidation, but oxygen is left behind. So here hydrogen will be your limiting reagent. You will always start your question from limiting reagents information. Though oxygen and hydrogen both were given, we will only go by hydrogen's value. So we will pick up hydrogen for our reference, and rest you know you will be writing by Gay-Lussac's law, all that terms you're going to use. So hydrogen is how much by volumes? 2 volumes. And 2 volumes is representing 200 cubic centimeter. So tell me 1 volume is how much? 1 volume is
One
how much?
volume 100 cc.
Correct, 100 cc. Okay, so
Oxygen will be 100 cc.
correct. And how much water is formed?
Water will be 200 cc.
Correct. Okay, now you can clearly see now for this reaction to happen, you have 200 cc of hydrogen. For that, only 100 cc of oxygen is sufficient for total combustion and it will form 200 cc of water. But in the sample, oxygen is extra. How much oxygen they gave? They gave 150. So how much is unused? 50. It will be 50 cc. This is extra oxygen which did not got used up in the reaction. So the final result will not just have water vapor, it will have that extra 50 cc of oxygen along with it.
plus O2 without CO2.
Correct. CO plus O2 with balance, you should write 2 CO plus O2 will give you 2 CO2. Okay,
2:1:2.
correct. 2 volume, 1 volume, and 2 volume. That
200 cc of CO.
okay, correct. It will be 200 cc. Now, why that? Because of course it needs oxygen, but oxygen, how much it is required for 2 volumes? Only 1 volume of oxygen is required. So definitely oxygen's requirement is less here. That is there for every question. And according to the sample, 200 is CO, and not even half, see, half of that will be required in the, that is technically without even calculation I can say that I have 200 cc of CO. If I wanted to go undergo complete combustion, just half of it, because the half of 2 is 1, correct? So half of that is required for the combustion, half of that oxygen is required. But I can see 200's half is 100 is the half of that, right? But here it is 300 given, so definitely oxygen will be extra, that will be left out. So in this case I will start with carbon monoxide. So 2 volume of carbon monoxide is representing 200 cc, 100 cc. Okay, so wherever I see 1 volume in my equation in the ratio, I will represent it with 1 cc. So if I have a sample of 200 cc carbon monoxide, how much oxygen I will require? Oxygen's ratio is 1 volume. Correct? Oxygen is 1 volume. That means how much oxygen I will require? 100 cc, because every time I see 1 volume, I can just write 100 cc. Also tell me how much carbon dioxide is formed. 200 cc of carbon monoxide is formed. Sorry, carbon dioxide is formed. So how much is that the resultant mixture? Are we only having carbon dioxide in the result? No, there is some extra oxygen which was not used. So tell me how much is the unused oxygen? Unused oxygen means they gave us 300, but we just took 100 for the reaction to happen. So 200 cc has gone waste. It's not being used up. It is unreacted. So there are two things in your result. First of all, carbon dioxide, and second is you would never write direct oxygen. Always write unused oxygen and write their volumes. Carbon dioxide form is 200 cc, and extra oxygen that was left is also 200 cc. So resultant mixture, never write it like that separately, add them and show it to them. Total 400 cc of gas was produced, mixture is produced in that. So my question is how much nitric oxide can be formed? Okay, so first work is write the equation. So quickly tell me what is the balanced equation.
Nitrogen N2 plus O2 gives you 2NO.
Correct. What are the ratios for them?
1:1:2.
Correct. 1 volume, and 2 volume. Okay, that means see 1 volume, 1 volume. See, go by your logical thing. 1 volume, 1 volume means same. That means how much nitrogen I have, I need to have same amount of oxygen. Okay,
Yeah.
if nitrogen is 500 ml, then how much oxygen should I have for complete work to happen? I should have same amount of oxygen. Okay, but I can clearly see oxygen, they have not given me 500, they have given me only 200. So will this give me total reaction? No,
No.
something will be left out. Which one is going to be
Nitrogen.
unused? Yes, it will be
Nitrogen.
nitrogen. Yes, so if I go by that, I will pick up the limiting reagent. I can choose oxygen, okay, because I know oxygen will be used up, but nitrogen will be still left out. So here oxygen will be my limiting reagent. Okay, so 1 volume of oxygen means 200 ml. Okay, and accordingly I should have had that nitrogen. So sorry, I should start with, no, we'll go by the oxygen only. So how much is the left out? 1 volume of N2 should also be technically 200, but in the sample they have given me how much?
500. So
500.
left out will be
So left out will be 300 ml. Okay, 300 ml. So one thing in the result is nitrogen, extra nitrogen is there. How much it is? 300 ml has gone waste. Waste means not used. And if I may ask how much nitric oxide is formed, then
If it's 2
And
volume, then
400.
it's 400
200. So take double of 1. So that's how much?
ml. 400 ml.
400. Yes, it will be 400 ml of NO. So if I have these kind of questions, you should always think what is extra, what is going to be used up totally, and what is left out. That will only come from the knowledge of that ratio. If you understand ratio very well, okay, 1 and 2, that's why it is in whole number given to you. 1, 3 also can also be there, right? So one volume, everything has to be started with one volume. Whichever you find the easiest, pick up that. You get that idea, okay, something is going to be left out, or sometimes even total combustion can happen. So that totally depends on equation and the ratio. Okay, and with balance properly, it is 3 for hydrogen. That's going to give me ammonia. The ratio is 1:3 and 2. Correct? 1, 3, 2. Now, if I may ask, when I am only comparing nitrogen and hydrogen, which is taken in more amount? Which should be more in amount, if I may ask you? I'm not giving you the sample right now, but looking into the ratio, which is taken in more amount, hydrogen or nitrogen?
Hydrogen.
Hydrogen, correct? So if I give you a sample where 400 ml of nitrogen is given and 300 ml of hydrogen is given. Hydrogen is 300, nitrogen is 400. Will it be sufficient to burn?
No.
No. So, which is going to be used up totally? Hydrogen or
Total will be
nitrogen?
hydrogen. Hydrogen.
Hy- yes, hydrogen will be used up and nitrogen will be left out. Okay, so limiting reagent will be hydrogen here.
Hydrogen.
Yes, so you will start your work with hydrogen.
Wait,
So
ma'am.
hydrogen,
So the element which is being used up the most is considered the
yes,
limiting
those are the
reagent.
limiting. Yes, those are the limiting reagent. Because if
Okay.
they are not left, then the reaction will stop. See it vice versa. Okay, sometimes it depends on the ratio. You got that here, hydrogen has to be more in amount as compared to nitrogen. That is why hydrogen is the limiting reagent in this question. But if I would have given you nitrogen is 500 and hydrogen has to be 3 times of that at least, correct? That's 1:3 means 3 times of that is 1500. And I am giving a sample that, okay, I'm giving some extra also, 2000 ml of hydrogen. In that case, what is the limiting reagent?
Nitrogen.
Nitrogen, because nitrogen will be completely used and at least around 500 H2 will be left out. So it depends on the sample given to you, but the fixed thing you need to check is the ratio, which is more and which is less, and then check the sample given to you. So not always hydrogen will be the limiting reagent. It depends on the sample available. So, so we will start with the limiting reagent. 3 volume is 300 ml. That means 1 volume is
100.
100 ml. Okay. So tell me how much nitrogen will be used and how much ammonia is formed.
Nitrogen will be 100 and ammonia will be 200.
Correct. Yes. So how much nitrogen is left out? They gave us 400, but only 100 got used
300
up.
ml. 300
So
mLs.
yes, unused will be 300 ml. Clear this
Yes,
question?
ma'am.